Organizations generally don't fail for lack of information. They fail when the right information is not available at the right time. Today, I will show you how we turn thousands of PDFs, pages, and portals approximately of terabyte size into a trusted and scalable answer system. It's not just a toy chatbot, rather, it's a trusted intelligence which help teams move faster, make fewer mistakes, and trust the results. Here is a real moment which made us to work on this chatbot. In the morning, our returns and refunds policy was updated, as in the free returns changed from 30 days to 14 days in the official document. Later in the day, a support agent answered a customer using an old internal note that still said 30 days. The customer then later tried to return a product on day 20, but the warehouse rejected it based on the new policy. But the customer showed our agent's message promising 30 days. So, here to protect the relationship, we honored the older promise. We paid the shipping, waived off the fee, and also gave a goodwill coupon. So, that's real money and lost trust. This wasn't actually a search issue here. It was a confidence issue, as in we couldn't guarantee the answer was correct, current, and citable. That's why we built an enterprise RAG system that always surfaces the latest and approved policy with citations. For us, the biggest challenge here was at terabyte scale, little problems do turn into expensive ones, like millions of tiny files slowing everything, new versions silently replacing old truths, scripts that used to work earlier now letting errors slip into the production, and then there were reprocessing costs as well. So we did not just scale a chatbot, we engineered a system. Our goals were pretty simple here. So let me just go through them one by one. So first was store cleanly so versions and lineage are obvious. Then automate so updates happen the same way every time. Validate before moving to production. Retrieve by meaning, not just the keywords. Explain with citations so people can actually trust it, and improve continuously with feedback and change detection. Let me walk you through our architecture. So here on the left side, we have ingestion and indexing, which shows how knowledge gets in. On the right, we have serving and retrieval, which shows how answers come out. Let me first focus on the ingestion and indexing, which is our data plane as well. I have zoomed it out a little bit for better visibility. So all new or updated documents land in Delta Lake on S3. Think of Delta as neat shelves with a logbook. It gives us safe writes, schema evaluation as things change, and time travel to roll back if needed. Here we keep three areas: raw documents as they arrive, process chunks, which is cleaned and splitted text into small and useful pieces, then the embeddings, which are the math fingerprints of those pieces. Airflow runs the same steps every day: ingest, preprocess, embed, and indexing. It takes raw data from Delta Lake as an input, then it performs cleaning and chunking and then generating the embeddings. It writes process chunks and embeddings back to Delta and also pushes doc version or hash to DynamoDB. Once we have process chunks and embeddings, Airflow triggers Glue and Athena to validate the data. So Airflow is safe to rerun, it has retries and logs everything. When the load is heavy, it fans out to Glue so we can process huge volumes. Before anything touches production, we run validation checks. Glue crawlers read processed and embeddings to register tables. Athena checks if row counts match to what we expect. It makes sure there is no null text. It also verifies if the embedding dimensions are correct or not and makes sure the freshness of data, as in new partitions, should be present. If any of these checks fail here, Airflow will stop indexing and raises an alert. After validation, if everything looks good, Airflow upserts embeddings into quadrant, which we have on ECS. That's our first find by meaning index. We shard by dataset and use replicas for high availability. For large loads, we bulk index directly from the embedding tables. This covers our ingestion and indexing part. Now let's move to serving and retrieval part. This is our serving and retrieval part. When a user asks a question, the request hits our load balancer and then our FastAPI service. FastAPI retrieves the most relevant chunks from quadrant and builds a clear prompt with that context and then calls Bedrock to compose a grounded answer. Bedrock is the LLM runtime that writes the answer and gives it back to FastAPI to be returned back to the user. The model stays grounded because FastAPI passes real passages from our documents. We also ask it to include citations. That's how we help keep up the trust with our user. DynamoDB stores user feedbacks from FastAPI. It helps the system to learn which answer needs improvement. As we have seen in ingestion phase as well, it also stores document versions and hashes from Airflow, which helps in drift detection. So when a document's hash or version changes, or if there are negative user feedbacks for a content, the next Airflow run re-embeds only the changed or required parts, revalidates it through Athena, and reindexes the quadrant. That keeps answers fresh and it also helps keeping costs down. CloudWatch watches everything: your Airflow runs, ECS services for FastAPI and Quadrant, Bedrock latency, Athena queries, and DynamoDB throughput. If a validation fails or latency spikes, we get alerts before users even feel it. To keep speed high and bills sensible, we compact small files in Delta, partition by date and dataset, use bulk indexing for big updates, and keep observability on everything. Here is what this solution will be delivering. First is speed. It will provide answers in seconds rather than spending hours of hunting. Then confidence. Validated data and citations used in this solution will help reducing the mistakes. Cost control, we only reprocess what's getting changed. And last is adoption. People trust it because it's auditable and current. If you are building this, remember, Delta Lake is your source of truth. Airflow is the automation belt that keeps the knowledge in this whole system updated. Glue and Athena are the safety checks before production. Quadrant is the fast index you search. Fast API is the conductor that puts it all together. Then Bedrock is the writer that explains using your content. DynamoDB is the memory for versions and feedback. And last and not the least, CloudWatch, which is your dashboard.